So picture a man who has been completely paralyzed from the neck down for 8 years. He
Right.
is sitting in front of a computer screen. His hands aren't moving at all. He's not using a breath control joystick, and he's not using eye tracking software either.
Right.
But on the screen, he is actively crushing his opponents in a video game. I mean, he's moving the cursor, he's executing commands, he's typing out the word hi to the outside world.
Which is just wild.
It really is. And how is he doing it? His brain is wired directly into the machine.
Yeah.
So, welcome everyone to another deep dive. Today's mission is to explore this fascinating breakdown of futuristic technology, and we are scaling all the way from a $10,000 medical device to a $1 billion space program.
It's a massive scale.
It really is. We are looking at an innovation landscape that sounds completely impossible, but is actually functioning today.
Yeah, and what links all these advancements isn't just their massive price tags, it's how they systematically remove the physical limits of being human. Every single piece of technology we're going to look at today is designed to bypass a barrier that biology or physics just placed in our way.
Right. And I want to emphasize to you listening, this isn't just about cool gadgets. This is a shortcut to understanding where humanity is headed.
Yeah, a literal roadmap.
Exactly.
Yeah.
Whether you are prepping for a tech meeting or you're just insanely curious about how the world works, this deep dive will give you a roadmap of the future.
Yeah.
So before we look at how we will live on other planets, we have to look at how technology is upgrading our own physical bodies right now, like on a personal scale.
Right, starting with the biology.
Yeah. Let's start with that $10,000 piece of tech I just mentioned called Neuralink.
Right, which is a surgically implanted computer chip designed to interface directly with the human brain. The man you mentioned, Nolan, is the proof of concept.
Yeah, the guy playing the video game.
Exactly. But we really need to pause on the mechanism here because the how is what makes this a paradigm shift. The Neuralink is actively reading the electrical signals in his brain.
Right, so it's not guessing what he wants to do based on external cues or twitches.
Precisely. Your brain communicates through electrical impulses called action potentials.
Mm-hmm.
So when Nolan simply thinks about moving a cursor to the left, his motor cortex fires a specific pattern of electrical signals.
Wow.
And the implanted chip captures that exact biological pattern, decodes it, and translates it into a digital command to move left on the screen. He is effectively bypassing his severed spinal cord entirely.
Which is just incredible. He actually said, anything anyone can do on a computer, I can do.
Yeah.
His hands are completely still, but his mind is driving the hardware. And we see this exact same principle applied to another incredible piece of medical tech, which is a $25,000 bionic arm given to a 12-year-old boy named Kai.
Right, Kai. So Kai was born without an arm, and historically the physical limit for a prosthetic was purely mechanical.
Like the old hook and cable systems.
Exactly. Older prosthetics often rely on mechanical pulleys. You shrug your shoulder to pull a physical cable, and that tension closes a hook at the end of the arm.
But Kai's arm uses advanced sensors built right into the socket where the prosthetic attaches to his body.
Yeah. What's fascinating here is the shift from those mechanical solutions to neurological integration. The sensors in that bionic arm are designed to pick up the actual residual nerve signals traveling down his limb.
Wait, so it's reading his nerves?
Yes. When his brain sends the command to flex his forearm or close his hand, the muscles in his residual limb twitch, microscopically. The sensors read that biological command, run it through a pattern recognition algorithm, and tell the bionic hand to grab a piece of wood.
That is straight out of a movie.
It really is.
Yeah.
We are no longer just building tools for the hands to hold. We are integrating tools directly into the nervous system.
Okay, let's unpack this. It's like we're upgrading the human body from a clunky dial-up modem to a direct fiber optic connection.
Oh, that's a great analogy.
Right. With dial-up or those traditional mechanical prosthetics, you're translating a physical shrug into a cable pull. The bandwidth is tiny, it's really slow, and it's prone to error.
Yeah, lots of lag.
Exactly. But with sensors reading the nervous system, you're tacking into the body's high-speed fiber optic network. The intention to move travels instantly.
That is a brilliant way to look at it. We are massively increasing the bandwidth between human intention and physical action.
So Nolan's Neuralink proves that technology can decode chaotic biological signals into clean digital paths. And that exact same decoding principle is what makes the next leap possible.
Right, scaling it up.
Yeah, because once we bypass the physical limitations of the human body, the very next step is bypassing the physical limitations of the world around us. And that starts with the absolute bane of human existence, which is the daily commute.
Oh yeah, the gridlock of modern infrastructure.
It's the worst.
Mhm.
So let's scale up to transportation. If you have $150,000 right now, you can just buy a flying car.
Just like that.
Literally. In a race against a normal car navigating a city, the flying car just takes off and flies in a straight line to the destination.
And the math on that is what drives the innovation here. By taking a straight path and basically ignoring winding roads, stoplights, the asphalt layout, you radically reduce travel time.
Yeah, the data on this suggests taking a straight path through the sky could save the average commuter 1,000 hours a year.
1,000 hours, that's unbelievable.
It's life-changing. And if you don't want a flying car for $500,000, you can get a jetpack.
Naturally.
Yeah, it hits 80 miles per hour with a 3-mile range, so short bursts of incredibly high energy. Or, if you want to stay on the ground for $1 million, there is a car equipped with 2 vacuum fans, so powerful it has enough suction to literally drive upside down.
Which is an incredible engineering hurdle, by the way.
I can't even picture how that works.
Well, to drive upside down, you have to create aerodynamic downforce, or in this case, sheer vacuum power, that exceeds the physical weight of the entire vehicle and its battery payload. You are quite literally defying gravity through mechanical force.
That is insane. But the transportation tech that completely blew my mind was the $10 million Mercedes concept car. It's actually inspired by the movie Avatar.
Right, the Pandora-inspired one. The design philosophy there is radically different from a traditional vehicle. They actually describe the car as acting like a creature.
Yes. If you touch it, it reacts to you. You push a center console forward to go, you pull back to stop, and you can even twist it to drive sideways.
Like a crab walk.
Yeah. But the biometric integration is what makes it feel alive. The chairs physically pick up your heartbeat and all your vitals and then automatically adjust the temperature and environment of the car for you.
Which completely removes the cognitive load of adjusting your own environment.
Right. You don't even have to touch the AC dial.
Exactly. And we shouldn't forget the logistics side of bypassing infrastructure either. The winged drone delivery system.
Right. Delivering s'mores ingredients to the middle of the woods in minutes.
Yep.
And this isn't some beta test prototype. They've already delivered over 750,000 packages directly to people's doors.
Which is a massive scale.
Mm-hmm.
When you look at all of these together, the flying car, the jetpack, the suction car, the biometric Mercedes, the delivery drones, you see a very clear pattern.
Right.
Transportation is shifting from infrastructure-dependent travel to dynamic point-to-point mobility. It's about total environmental adaptation.
Wait, hold on. I need to push back on this a little bit.
Okay, go for it.
If everyone starts taking these straight paths in flying cars to save 1,000 hours a year, aren't we just moving our traffic jams from the asphalt up into the clouds? I mean, we can barely get self-driving cars to navigate a 4-way stop right now without glitching out. Are you saying we're supposed to trust an invisible digital web to keep thousands of 5,000-pound flying vehicles from crashing into our roofs?
It's a highly critical engineering hurdle, I'll give you that. But the answer lies in automated air traffic control systems driven by artificial intelligence.
So no human pilots.
Exactly.
Yeah.
You absolutely couldn't have thousands of human drivers independently navigating 3-dimensional airspace over a busy city. Human reaction time is just too slow.
Right, we'd crash immediately.
Yeah, it requires an invisible digital infrastructure where AI manages flight paths in real time. It's decoding the chaos of the sky and preventing collisions milliseconds before a human could even process the danger.
Which requires a level of absolute flawless trust in the technology that I'm not sure we have yet.
It does.
Yeah.
But the transition from 2D roads to 3D airspace demands that computational leap. There's no way around it.
Okay, so moving around instantly point to point is great. But wherever we fly or drive upside down, we still need to eat.
True.
And we still share a very fragile biological ecosystem with millions of other species. So how does technology solve our biological limits on a resource scale?
This is where we transition from physics and aerodynamics to cellular biology. Because the physical limits of traditional agriculture are becoming a massive bottleneck for human growth.
Right. So let's talk about a $200 million technology from a company called Upside Foods. They are producing hundreds of thousands of pounds of chicken meat without killing a single chicken.
Yeah, the mechanism here is called cellular agriculture.
Yeah.
And it's really vital to understand how this differs from, like, plant-based alternatives like Beyond Meat.
Right, because if you're listening to this and thinking, there's no way I'm eating meat grown in a lab, that sounds like a science experiment. You aren't alone.
It sounds weird at first.
It does, but let's look at the biology. In 2018, they took a small amount of cells from a chicken egg, just one egg. They froze those cells at negative 80 degrees.
Right.
Then, when they want to grow meat, they thaw the cells, put them in a cultivator that basically simulates a chicken's body, and feed them protein, fat, and sugar.
They are providing the exact same biological building blocks a live chicken would consume. But it's not just a vat of multiplying mush.
Right, nobody wants to eat mush.
Exactly. To get the texture of meat, they have to provide a biological scaffold so the cells know how to organize themselves into muscle fibers.
Wow.
They are essentially tricking the cells into believing they are attached to a real skeleton, allowing them to form structured, realistic tissue.
And the cells just multiply based on that architecture. They literally produce a chicken's worth of meat every few seconds.
It's incredibly fast.
And because it's grown in this highly controlled environment, there's absolutely no disease. And the craziest part, they did a blind taste test with a professional chef, Nick DiGiovanni.
Oh, yeah.
He compared it to traditional chicken, and he honestly couldn't tell the difference at all.
Because biologically, at a cellular level, there is no difference. Your body literally cannot tell the difference because it is real chicken tissue.
That is wild. But the biological engineering doesn't stop at our dinner plates. Let's look at Colossal, which is a $400 million project focused on the science of de-extinction.
De-extinction. This is pushing the absolute boundaries of genetics and cellular manipulation.
They have a real fossilized woolly mammoth tusk from Alaska that is 43,000 years old.
Yeah.
And the scientists use a highly precise laser to literally pierce a cell and clone the DNA from that ancient tusk.
Which requires unbelievable micro-precision. I mean, you have to penetrate the cell wall to extract or insert genetic material without destroying the nucleus.
Exactly. They mixed that ancient mammoth DNA with mouse DNA to create a woolly mouse.
Right.
Which was essentially a proof of concept to test the viability of the ancient genetic material.
Yeah, it proves that the 43,000-year-old code can still be read and executed by a living biological system today.
And they have already used these techniques to resurrect the extinct dire wolf.
Yes.
There's this incredible detail in the source where they feed this resurrected dire wolf a cake made entirely out of meat.
A meat cake.
A meat cake. And they confidently state they will have living, breathing woolly mammoths back this decade. Plus, they've built a biovault containing the DNA of over 1,000 species that are currently at risk.
If we connect this to the bigger picture, this represents the total decoupling of consumption from destruction.
Okay, what do you mean by that?
Well, for all of human history, biological growth meant biological extraction. To get meat, something had to die. To expand our footprint, a species lost its habitat.
Right.
Now, we are acting as an undo button for extinct ecosystems. We're producing endless food and restoring apex predators through sheer biological mechanics.
Here's where it gets really interesting. So essentially, we've invented a biological 3D printer for our food and an ultimate cloud backup for the entire animal kingdom.
That is the perfect way to conceptualize it. The BioVault is a literal hard drive for biodiversity. If a species crashes in the wild, you don't lose the data.
You just download it again?
You simply reboot it from the genetic backup.
Okay, so that naturally leads to the ultimate question. If we have a cloud backup for the animal kingdom, what is the backup drive for humanity itself?
And that brings us to the planetary scale.
Right. There is a $500 million facility called Biosphere. It's essentially a self-sustaining mini-Earth designed to be a functional blueprint for human life on Mars.
Because if you go to Mars, you can't just pack a really big lunch and hope for the best.
Right. There's no grocery store.
You have to bring the entire carbon, oxygen, and water cycle with you.
And they actually built it. It features 5 distinct massive biomes under glass. There's a rainforest that can literally rain on command to manage humidity.
Wow.
There's a savanna biome, which is ideal for growing food. They're actually growing ghost peppers in there.
Mm-hmm.
But the desert biome is what really fascinated me. They generate artificial wind specifically to strengthen the trees so they don't fall over.
We really need to highlight the core insight there. When they first started building enclosed environments, trees would just collapse under their own weight.
Why?
Because they realized that biology requires stress to build strength. Without the physical resistance of wind pushing against the trunk, The structural integrity of the wood, the lignin, simply doesn't develop properly.
That is fascinating.
It is a profound reminder that we are shaped by the friction of our environment.
Wow. That is incredible. They also have a vertical garden that can grow the equivalent of 2.5 acres of farmland in a tiny, optimized footprint.
Essential for space travel.
Yeah. And a swampland with plants that naturally taste like salty potato chips, which they noted would be perfect for seasoning boiled food on Mars.
Because you'd want some flavor up there.
Exactly. And an actual ocean with a wave-generating beach, all completely sealed inside this dome.
This raises an important question about the evolution of space travel. The ambition here has completely shifted from simple space exploration, like the Apollo missions planting a flag and coming home, to creating closed-loop multi-planetary survival systems.
Right.
To survive on Mars, you have to master the absolute perfection of recycling every single atom of oxygen, water, and nutrients indefinitely.
But you still have to get all that stuff, the biosphere materials, the people, the vertical farms, all the way to Mars. Which brings us to the $1 billion SpaceX Starship.
The delivery mechanism for this multiplanetary future.
This rocket is massive. It's designed to hold 100 people per ship. And what is so staggering is the manufacturing process.
Yeah, it's totally different.
The SpaceX facility isn't operating like a traditional bespoke aerospace lab. It is a massive assembly line. They are churning out rockets the way Ford churns out cars.
That is the paradigm shift in aerospace. It's the transition from custom-built, disposable crafts to the mass production of fully reusable rockets.
Reusable is the key word. When these massive rockets re-enter Earth's atmosphere, they face friction temperatures hotter than molten lava.
Right.
So SpaceX engineered a custom heat shield system using 18,000 individual tiles per ship. To demonstrate how this works, they actually took a blowtorch to one of these tiles.
I saw this.
Yeah. The torch was blasting at over 2,000 degrees, turning the front of the tile glowing, violently orange. But the person holding the back of the tile with their bare hand felt absolutely zero heat.
The thermal displacement is just unreal. The material is so poor at conducting heat that the energy simply cannot travel through the thickness of the tile.
It's basically magic.
It radiates the heat back out rather than letting it pass through to the steel hull of the ship or, the hand holding it.
And if you can mass produce a ship that holds 100 people and mass produce a biosphere that can sustain them, the math on becoming a multiplanetary species suddenly becomes very real.
It does.
But I have to ask, so what does this all mean? If we can perfect a biosphere dome that perfectly sustains life, grows food vertically in a fraction of the space, and manages its own weather, doesn't that exact same tech just make Earth infinitely more livable first before we even pack our bags for Mars?
It absolutely does. And that is the dual-purpose beauty of this engineering. The technologies required to survive a hostile, barren planet like Mars are the exact same technologies required to hyper-optimize a planet like Earth.
I see.
If you can grow a rainforest in a glass dome and print hundreds of thousands of pounds of meat from a few frozen cells without vast pastures, you can completely rewild massive portions of the Earth that we've previously paved over for agriculture.
It's staggering to think about the trajectory we've just walked through today. We started this deep dive talking about Nolan typing a simple hi on a screen by just thinking about it, decoding the electrical signals of his brain.
Yeah.
And we ended by talking about mass-producing billion-dollar rockets to carry self-sustaining, closed-loop biomes to Mars.
And the most important thing for you, listening to this, to remember is that this future isn't just something happening to you. Every massive piece of technology we discussed, from the Neuralink decoding brainwaves to the laser piercing a 43,000-year-old mammoth cell, started as just an idea in someone's mind.
Exactly.
And the barrier to entry for building this future is dropping rapidly.
Right, because it's not just billionaires building this stuff. The data explicitly points out that with new tools like AI co-founders, they specifically mentioned Shopify's Sidekick tool, everyday people now have the power to build the future themselves. Sidekick can help set up entire digital infrastructures, draft complex marketing plans, and handle routine operational tasks. It gives one individual the leverage that used to require entire teams of people.
It democratizes human ingenuity. The tools to execute a world-changing idea are no longer locked behind massive corporate walls.
Which leaves us with a truly wild reality to process. I want to leave you with a final thought to ponder as you go about your day.
Okay.
We've talked about removing the physical limits of humanity. If we can eventually clone extinct animals from ancient tusks and keep their DNA on a hard drive,
Right.
and if we can grow endless meat in labs without ever farming an animal, and if we can live in perfectly climate-controlled biospheres on Mars or Earth, what happens to our concept of nature?
That is the ultimate question of this new era.
Will the Earth of the future be a wild, untamed place where biology runs its natural course? Or, as we systematically bypass every single physical and biological limit evolution placed on us, will our home planet just become a giant, carefully curated museum that we occasionally visit from the stars? It makes you wonder. When we look back at the timeline of human progress 1,000 years from now, it won't look like a slow crawl of stone tools to bronze tools. It will look like a species that suddenly decided to grab the pen and rewrite the laws of biology and physics themselves.
A species that stopped adapting to its environment and started adapting the universe to its imagination.
Exactly. Keep questioning the limits. Thanks for joining us on this deep dive.